Okay, here's some more problems on section 4.5. And again, these are linearizations, and some of these kind of work out to seem a little bit more trivial, but they work, so we can take a look at it. Now, they're not terribly accurate, but they do work. Well, actually, they're fairly accurate. Okay, so if we look at this function, x plus 1 over x around 1, and this was going to be our a, so we're going to just add 1 to that, so that'd be 1.1. So this is what we're going to put into our linearization. X equals 1. If I put 1 in here to find out the y value, y equals 2, so my point was 1, 2. That's my point of tangency, right around when x is 1. And then I find the derivative to find the slope, because I want to find the equation of the tangent line when x is 1. That's basically all we have to do to get started. So the derivative of the x is 1, the derivative of 1 over x, remember that was the formula we learned, negative 1 over x squared. Okay. Okay, we've got that. And then we want to evaluate that when x is 1, so I put 1 in there. I get 1 minus 1 over 1 squared, which ends up being 0. So the slope of my tangent line is 0. So I put this into my equation, and I get y minus 2 equals 0 times x minus 1. Well, that just zeroes out, so I end up with y equals 2. That's my linearization. That's my tangent line. It's a horizontal tangent. Okay. So no matter what I put in here, I'm going to get 2. So 1.1 would be 2. Let's see how close that is. Hopefully it's close. As long as it's close to the point of tangency, then it won't be too bad. Now if we get, as we move away from the point of tangency, it's going to, the error is going to increase, pretty fast, I would imagine. Depending on the line, how flat it is, maybe it flattens out in that area. Okay, so let's take a look at this. So the error. So first of all, like I said, my linearization is always going to be the same, so it's going to be 2. So f of x minus L of x, f of 1.1 minus L of 1.1. Well, if I put 1.1 into the original function, so if I take 1.1 plus 1 over 1.1, evaluate that. Okay, and I take the difference. What I did was I got 2.009. So again, the error was the value of the function with the calculator minus the linearization. So I got 2.009 minus 2, so I got 0.009. I wrote that as a fraction, 9 over a 1 followed by 3 zeros, or 9 thousandths. But 9 is less than 10, so that's less than 10 over 1,000, which is equal to 100. So my error was less than 10 to the negative 2, or less than 100. Okay, and then number 4, let's take a look at that. Okay, this was my function, the natural log of x plus 1. Now my a was 0, so I want to find my linearization at a plus 0.1, which is 0.1. So x takes on the role of a, so x equals 0. What would y be? Well, if I put y into this function, the natural log of 0 plus 1 is the natural log of 0. I'm sorry, the natural log of 0 plus 1 is the natural log of 1. E raised to what power is 1? 0. So my point was 0, 0. Now let's go see what the slope is. So I take the derivative of the natural log of x plus 1, which is 1 over x plus 1. I substitute 0 in there, so that's 1 over 0 plus 1, which is just 1. So that's the slope of my tangent line. So this is my point of tangency, 0, 0, and this is my slope. So y minus 0 equals 1 times x minus 0. And I just end up with just y equals x. So that's my tangent line at that point. So the L of x is just x. That's the tangent line. Now in order to find the error, okay, well first of all, like I said, it's just going to be x, so L of 0.1 would be just x. I mean, it would just be 0.1. That's identity. Okay. So what's the error? Well, if I put 0.1 into this, I take the natural log of 0.1 plus 1, which is 1.1. And I calculated it out. I got, in my calculator, I got 0.0953, so you could check that out. I ran it off a little bit. And minus my 0.1, because that's the value I got, because it was identity. L of 0.1 is 0.1. And then I took the difference. I got negative 0.0047, but it's the absolute value of the difference, so it's just 0.0047. And 47 is So it's 47 over a 1 followed by 1, 2, 3, 4 zeros. But 47 is less than 100, so I'll write it as 100, so I can cancel out some more zeros, and I've got 1 over 100, or 10 to the negative 2. So the error, I would say, is less than 10 to the negative 2. Okay, so I hope those help, and you can finish 5 and 6, hopefully. But I'll try to get those done a little bit later. Good luck.